So this video is going to serve as a tutorial to get you started on the drawing the Bohr model of an atom assignment that you're going to be working on in class. So one of the things that we should know is we just got out of our atoms unit and we studied what we call the different subatomic particles of the atom, which are the smaller particles that make up an atom. And so we talked about three in particular. And so the first question is asking which of the ones that are located in the nucleus. So which of the two of the three are found in the center of the atom. And so if you look at my little diagram here in the top right, I see in the center, which represents the nucleus, this 12N and this 12P. Those N's and P's stand for our protons and our neutrons. So those are our two smaller particles that make up atoms that are located in the nucleus. The other subatomic particle that we have is the one located on the outside, okay, and what we call the cloud. And those, as we know, as we're studying electrons right now, are our electrons. Okay, so those are the three particles we're going to be looking at when we start drawing what we call Bohr models of an atom. So Bohr was a scientist and he discovered what we call the planetary model of the atom, which says that electrons orbit in these different paths around the nucleus. Some electrons are close to the nucleus, some are far away. Okay, and as we learned in class for our electron configurations, these electrons exist in these things that we call energy levels. Okay, so the energy level, the first one is the first one that's the closest towards the nucleus. Okay, it's that first circle on the outside. All right, and so what we would say is that that first new energy level, which is represented by this circle right here, right, n equals 1, this first darkly bolded circle is our first energy level, and it says, according to Bohr, that we can only hold up to 2 electrons in that level. Okay, so if I were to go draw this in, the way I'm going to draw it here is I'm going to draw it like two sort of circles with negative signs in them to represent a negatively charged particle. Okay, so those are 2 electrons that can fit there. All right. And so that first energy level, as we know, is actually made up of one sublevel that we call that 1s2 subshell. Okay, 1s2 is composed of one orbital, so it can only hold 2 electrons. Now the second energy level can hold up to 8 electrons. Okay, and I'm going to represent that with in yellowish goldish color. Okay, so for example, in our electron configurations, if I look in the second energy level, right, if I look at my periodic table, the second energy level is the second row of the table itself. So it would be like this row in the periodic table. So if I count across the number of elements that go across the second row, which is the second energy level, I get 1, 2, 3, 4, 5, 6, 7, 8, which means that I can hold in 8 electrons in that second energy level. Okay, so across the s block, we get that 2s2 configuration, meaning we can hold 2 electrons in that 2s sublevel. And across the p block, I have that 2p6 configuration. Those exponents, that little 2 and that little 6, add up to 8. Okay, so as we're looking at how many electrons can fit, we can either count the squares of the elements on the periodic table or look in our electron configurations at the exponents. Okay, so we can hold up to 8 electrons there. All right, finally, if I look at the third energy level, this one's a little bit more tricky, okay? But this one can hold up to 18 electrons. So again, we can go back to that periodic table there, and we can look in the third energy level. So the third energy level would put us at sodium and magnesium here. And so I would have 3s2 if I count 1, 2 electrons here. I would also clearly have this p block. So again, I would have 6 electrons from the 3p sublevel, okay, if I count all the way across. But remember, the 3d block, even though it's the 4th row down on the periodic table, 3d is still filling electrons in the third energy level of an atom. So we would also count these 10 elements across the d block, each as an electron. And so that adds 10 plus 2 plus 6. This 3d10 would also be added to our electron total. Okay, so we'd have a total of 18 electrons in this energy level, right? So if we did something like 3s2, 3p6, okay, 3d10, right? Those all count as our electrons here, okay? So that's our general rule, all right? These are how many electrons fit in each level, okay? So one of the things that we want to do is we want to look at the information that's given to us and then kind of deduce from there what to do. So this question is asking you how many protons, neutrons, and total electrons are there, all right? So let's take a look at figuring that out. If I have a mass number of 16, based on our last unit, we know that the mass number is our protons plus our neutrons together, because that's the weight of the nucleus, all right? So let's go ahead and look up oxygen and see if we can find out how many protons it has based on its atomic number. So in looking up oxygen, I see that I have 8 as my atomic number, which means that I have 8 protons. All right, so if my mass number is 16, remember, it's protons plus neutrons equals mass number, so that would mean the remaining 8 of my mass number would come from my neutrons. So there are 8 neutrons. Finally, since this is neutral, that means with the number of electrons and protons are the same, so all our numbers are just going to happen to be 8 here. Okay, and that's a special case. That doesn't always happen, but it does happen in this example. Okay, so what I'm going to do here is I'm going to go to my Bohr model, and I'm going to draw in my 8 for my neutrons and my 8 for my protons. All right, so this inner circle here, what you're seeing on the very inner part, that's our nucleus, because that contains our protons and electrons. And outside the nucleus, right, these darker rings, these are our energy levels. Okay, so this is energy level 1 here, energy level 2 is the second dark circle, and energy level 3 is the third. Okay, and what you should notice is that these energy levels get progressively bigger and bigger the farther you go out from the nucleus, because that makes sense as our capacities for the number of electrons also go up. So in looking at our first energy level, what we're going to do is we are going to place the maximum number of electrons we can place there. Okay, and it looks like we can only place 2 in the first energy level. So we only have 1 orbital in the first energy level. So we're just going to draw a pair of electrons together there, right? And now it doesn't matter where you draw this pair. You can draw it on the bottom like I did, on the top, on the side, wherever you want to draw it. As long as you know that they exist in that pair, that's fine. Okay, there's only 1 orbital there, so they have to pair up, even though they try to go in singles first if there's more orbitals available. So the next thing that we're going to do is we have 2 down, we got 6 to go. That means we're going to move on to the next energy level, which is n equals 2. So in n equals 2, we can fit up to 8 electrons. We only have 6 left to give. So what we are going to do is we are going to go ahead and we are going to draw out the remaining pairs, okay, in the second energy level. So as you remember, in the second energy level, we can fit up to 8 electrons. So what I'm going to do is I'm going to draw them on their own first, because there's more than 1 orbital in this next energy level here. So I have 4 down, and then I'm going to pair up whatever ones I choose with the second electron. Okay, so it could be the ones to the left, like I did. You could have paired up the ones to the right. As long as you know that there's 6 total electrons there, I'm pretty much good. But technically, we won't pair them up if we don't have to. Okay, so the only energy level where you'll pair them up right away is the 1, because there's only that 1s orbital or sublevel in that orbital or in that energy level. For the others, you're going to want to put them as singles first and then double them up once you exceed the number maximum. All right, so we have 2 electrons in the first energy level here, and we have 6 electrons in the second energy level, if we count up all those electrons. That gives us to a grand total of 8, so we do not have any electrons in the third energy level for oxygen 16. Let's go ahead and move our way down. Okay, so I already filled out some information here within the protons, neutrons, and electrons, so hopefully you're good at doing that. What I did here is I filled in and I looked at the number of protons for sodium. So sodium has an atomic number here of 11, so that's where I got the 11 protons. I would get 12 neutrons from subtracting 11 protons from my mass number. And then the total electrons, if we're neutral, it's going to be the same as the protons. So let's go ahead and draw this in and see what we can figure out here. So as I mentioned, we are going to have 11 protons and 12 neutrons. And so as I look at this example, let's start placing in our 11 electrons. So as I said again, we can go to label our energy levels if you'd like to give yourself some bearings. And we're going to place in our 2 electrons and that first energy level first. There's only one orbital there. The 1s sublevel only has one orbital. Then what we're going to do is we're going to move out to n equals 2 and start placing in electrons. So the n equals 2 level can only hold up to 8 electrons, and we need to place 11, so that means that we're going to place all 8 into this energy level. So I'm going to go 1, 2, 3, 4, and then I'll place them into their pairs. Okay, so there's 4 total orbitals in the second energy level, so you're able to make 4 groups of electrons. Finally, I have the n equals 3 level. I have so far 10 electrons. That just gives me a spare electron to place on the very outside. Okay, so this electron on the very outside here, this is the last one I would put here, is actually an electron that can go anywhere. So as in anywhere within this energy level. Could put it on the side here, could put it on this side, could put it on the top. As long as it's in that n equals 3 level, that's good. That can go anywhere within n equals 3. All right, so let's take a look at doing phosphorus now. So phosphorus, this is your turn. So what I'd like you guys to do is try this one on your own, and we can go from there. All right, so hopefully you've tried this on your own. The first thing you should probably do is have a periodic table out so you can look this up. And let's look up phosphorus. Phosphorus is number 15 on the periodic table. That means that it's going to have 15 protons. It will also have, since the mass number is 31, 16 neutrons, and a grand total of 15 electrons since we are neutral or zero charge. All right, so we're going to do a 15 and a 16 here. Now let's start drawing our electrons in. All right, so in the first circle, we're going to have our first energy level. So let's place our 2 electrons wherever we like there. All right, make sure you just place them as a pair. And now we still have 13 left to go. So that means that we're going to completely fill out our second energy level. So we're going to go 1, 2, let me actually expand this out here. 3, 4, 5, 6, 7, 8. Now I'm at 10, right, total with 2 in the first energy level and 8 in the second. Now if I look back, it says on here that the third energy level can hold up to 18 electrons. We're never going to have you draw an atom that big, right? That would get into the configuration of like a transition metal that includes those d electrons, giving us those extra 10 in the energy level for 3. Okay, so we're always going to be pretty much above the d block, and so we'll be at a minimum at the third row on this periodic table. So we're just going to pretend like this third energy level is going to hold up to 8 electrons. All right, and so with the remaining 5, we're going to kind of do it similarly to the n equals 2 level. So I'm going to place and imagine that there's only 4 pairs of electrons that are going to exist here. So there are 4 right there. All right, and then what I can do is I can pair up and buddy up one of them. Okay, so to give us our remaining 5. All right, so that gives us that there. All right. So that is phosphorus. So why don't you guys go ahead and record down how many we have in each. So you should have gotten that we had 2 there. You should have gotten that we had 8 in the second energy level and 5 in the third. All right. Now, try out chlorine on your own. Again, get that periodic table out and look up chlorine's atomic number. Okay, so you've tried chlorine. Chlorine has an atomic number of 17. All right, so we got 17 protons. Mass number is 36, so 17 plus 19, last time I checked, gives us 36. And 17 electrons since we are electrically neutral. All right, so let's go ahead and place these around our atom here. And since we have 17 electrons, this will be very similar to what we just did, where we have all of our first 2 energy levels completely filled. So let's go ahead and fill those up. Okay, and then we're going to go here, 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 here. So we're going to have the maximum number of 8 in n equals 2. And then finally, we're going to have and remaining, it looks like 7 to place. So let's go ahead and place in those 7 electrons, just pretending like, you know, we're only going to be fitting 8 in this level for right now. So we have 2, 4, 5, 6, and then we have 7. Okay, so what you should notice is that we are missing this 1 electron over here is kind of a loner. All right, so as of right now, we have 2. We're at capacity in first level. We're at capacity in second level. And we're just under the capacity with 1 electron in the next level. All right, so one of the things we're going to learn in the next unit is why we form ions. Okay, and we kind of talked about it a little bit with electron configurations. Chlorine tends to form a -1 ion. So to form a -1 ion, how would I do that? All right, looking at this Bohr model, how would I make this a -1 charged item? Well, hopefully you came to the idea that you would just add in a extra electron here. And this extra electron, if you notice, completely would fill up our third energy level, giving it 8 electrons. And again, we're just pretending that 8 would fill it here. And that would make this very energetically stable. Okay, and that's one of the things that we're going to learn about in that periodic table unit. All right, the last thing we're going to talk about here is valence electrons. Okay, so valence electrons are the outermost electrons in the outermost energy level. So these are the very most outside electrons here, and these are the most interesting because they participate in chemical reactions, and that's why we're learning about them now. So going back to the examples above, list how many valence electrons are in each Bohr model. Okay, so I'll do oxygen. I'll let you guys try the other two. If I look at oxygen, right, and I'll look at my outermost electrons, we're going to look at the highest energy levels that the electrons are hanging out in. So in this case, it looks like it is the energy level of 2. So how many electrons are there? I have 2, 4, and I have 5 and 6. So I would say that the oxygen atom has 6 valence electrons. Okay. Now, what are those valence electrons? Well, if I were to do the electron configuration of oxygen, okay, we can kind of split screen with the periodic table to do this. Oxygen, right, would have the configuration of 1s2, 2s2, 2p4. So the outermost electrons in this configuration, right, we have the 1s2, we have the 2s2, and we have the 2p4, right, are the configurations that have the highest number in front of them as their coefficient. So that would be 6 total. Okay. All right, let's look at sodium. Sodium, right? Looking at the highest level electrons existent in sodium is 3. So it's this electron down here. That gives us 1 valence electron. Again, if I wrote out the electron configuration for sodium, okay, it would be 1s2, 2s2, 2p6, 3s1. That 3s1 is our valence electrons hanging out in that 3s sublevel in the third energy level. All right. Why don't you guys try out neutral phosphorus and neutral chlorine and come back and check your answers. All right, phosphorus. Checking out phosphorus. I have, if I look in my drawing, the third energy level is the highest level. So I have 2, 3, 4, and 5. So that would give us 5 valence electrons. Right? Neutral chlorine had 2, 4, 6, 7. All right, so hopefully this was a good primer for you guys to learn about the Bohr model of the atom. And at this point, you should have this activity completed. Go ahead and submit it and make sure that it is done.